Hello, my name's Thanom and I'm from UNSW. Today I'm working through some of the Math 1011 calculus questions on the section 2.3 under differentiation. So 12C is asking us to draw possible sketches of the derivative and second derivative given an original curve that's just given by a diagram, not by any equations. So we've got to consider the slope of this curve and graph what that function might be, the function that tells us what the slope is. So in doing these questions, I like to walk along the graph from left to right. If I'm walking along the graph from left to right, I can see that the slope here is positive. These are little plus signs. It's increasing. The slope is positive. Right at the top, the slope is 0. That's a stationary point. If the slope is 0 here, that means my derivative must be 0. My function must go through, have a dy dx must be 0 at x equals minus 1 there, because it's a stationary point. Continuing to walk along, the slope is negative. This is a decreasing on this interval until this point when x is 3, when the slope is 0. So at 3 here, dy dx is 0. So the function, the gradient function must be 0 here. And then we continue to walk along and it's increasing, so the slope is positive. So what these plus and minus signs mean is that dy dx must be positive for x values less than 3. So it must be above here somewhere. Dy dx must be positive here. It must be negative between minus 1 and 3, and it must be positive over here. And it passes through 0 at minus 1 and 3 because that's where the gradient is 0. So my dy dx function looks like this. It looks like a quadratic for a very good reason, because this pretty much looks like a cubic. And we know cubics differentiate to quadratics. X cubed differentiates to 3x squared. So if we did have an equation here for the cubic, then when we differentiated it, its equation would have been a quadratic. I might even make this quadratic a bit more symmetrical and have it with its lowest point at 1 there. Okay, so now, if I want to draw the second derivative, d squared y on dx squared, that's the second derivative, that's the gradient function of dy dx, right? That's looking at dy dx and drawing its derivative. So if I walk along this curve now, walking from left to right, I'm walking downhill, so its derivative, the gradient of the slope is negative there. Once I hit here, the gradient 0. So at this point 1, the gradient's going to be 0. So the second derivative, the gradient of dy dx is 0. That means the second derivative of this function is 0. So this is negative here, and as we go past that stationary point, the curve is increasing. The fact that it's increasing means its gradient is positive. So the gradient of dy dx is positive. Means that the second derivative is positive up here, the second derivative of the original function. So I need a graph that is negative for values less than 1 and positive for values greater than 1. So my second derivative, or my derivative of dy dx, is going to look like this. I've drawn it as a straight line because this looks like a quadratic. And quadratics differentiate to linear functions. X squared differentiates to 2x. So if this was a quadratic and I had an equation, I know that it would be a straight line graph here. But most important is that it's negative. The value is negative for x values less than 1. The value is 0 at x equals 1. And the value is positive for x values greater than 1 there. So we've started with a function and we've considered the slope of the function to draw a graph of what that slope is. And then doing it one step further, we consider the slope of dy dx to draw the second derivative, d squared y on dx squared. That should be a little 2 there. And that's question 12C.